Hi everybody. This is part 3 of 3.6, and we're doing average value. Now, I just wanted to show you this very nice diagram I have here in the textbook. So the average of a bunch of numbers is, let's say you have n numbers, like you have 10 numbers. You add up all the numbers and you divide by 10. That gives you the address. That gives you the average. If you have 20 numbers, you divide by 20. If you have n numbers, you divide by n. You just add them all up. 100 numbers divide by 100, whatever it is. But what if we need to find the average temperature over a day's time? They're like billions of split seconds, to add up. And how are you going to do this? Well, that's what you need calculus for. Calculus is when you have a very large amount of very small things. That's calculus. That's an integral. So the average value for the function is the integral from a to b of the function, which means the area, all this whole yellow area under the curve, divided by b minus a. B minus a, the length, that's comparable to here when there's 10 numbers dividing by 10. So that's what the dividing by b minus a is. And the area under the curve is like adding up all the 10 numbers or 1,000 numbers, or however many. In this case, it's, wow. Um, so, so what do we got here? We have the area of the curve. Now, this formula, if you think about it, this is such a great visualization. Imagine that this yellow stuff is liquid, and it just kind of like settles. So it now settles into this little area here because it's in this little tank, and all that stuff comes down. This stuff goes up, and it has this little rectangle. So the area of the rectangle, excuse me, is b minus a, this length here, times what really is the average of the function, and that is awesome. Um, let's look at example 4. Let's look at example 4. During a 9-hour workday, the production rate at time t hours after the start of the shift was given by the function r of t is equal to 5 plus square root of t cars per hour. I want to switch over to my other camera. First, I got to turn the camera on. That's the first thing I got to do. And I got to shut, oops, I got to shut this virtual background. Got to get rid of it. And there we go. Okay, now I'm going to switch cameras. Now I'm switching cameras. Here we go. Switching to, there we go. Okay, so let's do this. The There we go. So the average, what's going to be is the average value. We're going to follow the formula. We if you remember the function that we just mentioned, the aforementioned function was r of t equals 5 plus the square root of t. And that was cars per hour. So, all right, cars per hour. And the average hourly production rate, that's what we want, is going to equal, so average hourly rate is going to equal 1 over, now it's a 9-hour workday. So you started at time t equals 0 and you ended at t equals 9. So it's 1 over 9 minus 0. That's what we're dealing with, times the integral from a to b. Now, again, we're starting from 0 going up to 9. That's our 9 hours. And we have the 5 plus the square root of t dt. Now let's figure this out. Well, this is easy to integrate. This is equal to 1/9. This is, this is equal to 1/9. Now I want to just fix my screen. This is equal to 1/9 the integral from 0 to 9 of 5 plus t to the 1/2 power dt. And I made this, I did this because it's much easier in calculus to deal with exponents than with radicals, because you have the power rule. And this is equal to 1/9. Well, let's see, the integral of 5 is 5t. The integral of t to the 1/2 is 2 times t to the 3/2. Evaluate between 0 and 9. Now, why is it 2? It's really divided by 1/2, but dividing by 1/2 is the same thing as, I'm just writing here as a side point. T over 3/2 divided by 1/2, but this is the same thing as 2 times t to the 3/2. I'm just writing that as a little side point, a little algebra point. Anyway, this is equal to, let's see, well, when t is 0, then this whole thing just disappears, so I don't have to worry about it. So it's 1/9. Let's just look when t is 9. Well, when t is 9, that's 45 plus 2. Now, what does 3/2 mean? It means the square root of t raised to the third power. Well, the square root of 9 is 3. 3 to the third power is 27. And this is 1/9 times, let's see, that's 45 plus 54. 45 plus 54, which is 99. 45 plus 54, which is 99. And that just equals 11. And pow, that is the average production rate. And I stand on that. 11 what, you ask? Well, it's 11 cars per hour. It's 11 cars per hour. And that is the story. Now I want to show you an example from the textbook, because it involves drawings, which they do a better job of drawing that than I do. So I'm going to switch over to the textbook. And so this graph shows the amount of water in a reservoir over a 12-hour period. We want to estimate the average amount of water in the reservoir over that period. Let's see, I don't need the, give me 1 second. I don't need the, okay. So, we're over here. So in the, so V of T is the volume of the water in millions of liters after T hours. And the average amount is going to be 1/12. Why 1/12? Because it's 12 minus 0. It's a 12-hour period. So it's 1/12 times the integral from 0 to 12 of whatever this function is, V of T dt. Now, I can't integrate the function because I don't even know what the function is. How can I integrate a function if I don't know what it is? I mean, how can I get an antiderivative if I don't even know what the function is? So what we're gonna have to do here is we're gonna have to go old school. We're gonna have to attack this with little rectangles. We'll Riemann some thingy rectangles. So what we're gonna do is to find this number. This is a number. Remember, a definite integral is a number. It's not a function, it's a number. So in order to find the definite integral, we have to estimate. So we're gonna make 6 rectangles, which is nice. 12, 6 goes into 12. It's all nice and serendipitous. And we're going to take the height based on the right edges. So here's our first rectangle. Here's our second rectangle, our third rectangle, our fourth rectangle. Notice that the upper right corner of each rectangle is what touches the curve. So here's our fifth rectangle, the upper right, and here's our sixth rectangle. Again, the upper right is what always touches the curve. So this seems to be about 18 feet high. This seems to be about 9.7 feet high. This seems to be about 8.2. The height of this one seems to be around roughly right around 12. The height of this one seems to be about 19.9, and the height of that one seems to be 22. And of course, This is always a problem with visual, looking at a visual graph because it's a little hard to tell. But this is what we got. Anyway, uh, all of these numbers have to multiply by 2 because we're looking at the area of this rectangle. So the area is the height times the base, and the base is 2. In fact, the base for all of these is 2. Anyway, if you crunch this all out and add this up, you're going to get 179.6. And don't forget, that's the integral part. That's the integral part. We still have to divide by 12. We still have to divide by 12. So 179.6 divided by 12 is 15, is approximately 15 millions of liters. It's a lot of water. And again, you might have looked at this and kind of had different numbers because, like I say, we don't really have the same. We don't have precision. We're looking at a graph, looking at a sketch, and we're trying to estimate the height space on that. Plus, it's possible, you could make a left sided. You can make rectangles where the left side is the part that touches the curve, or the middle of the rectangle touches the curve. There's all different ways to do this, or you might have made 12 rectangles instead of 6 rectangles. There's always different ways to do this, but this is a nice little estimate. Why am I liking this estimate? Because I have 1, 2, 3 places where I go over the curve, and I have 1, 2, 3. I guess that little fourth place over there where I go under the curve. So you have plenty of over, plenty of under. Usually, when you have the overage and the underage, it kind of balances it out, kind of balances itself out. No guarantee, but it kind of usually often does. And so we're looking good here. I can't tell you the exact amount because I don't know what the function is, so I can't really tell you the exact amount. Anyway, let's go do let's go do another insight, because in this graph, what we did is we took that same graph we were just working on, and we drew this line. That's 15, and y equals 15. But why is it y? Where did the 15 come from? It came from here. That was our approximate answer when we divided, and and that will be the average. And again, I kind of like it because I have a little bit I have some overage on the ends. I have some underage in the middle. Kind of looks a little bit like the overage and the underage balances each other out. Again, you can't tell just by looking at a picture, but it's looking pretty good. So we're doing good here. Let's find the average value of the function function f of x equals 1 plus x squared on the interval -1, 2. Now notice I could draw the diagram, which would be, it's always nice. I think it's always nice to draw the diagram. It gives you a visual sense of what's going on. But we could do this without the diagram. We'll look at the diagram later. But right now we could look at it without the diagram. So let's just let's do the formula. So the formula is the average value. The formula is that the average average value and is going to be some people, by the way, some people write this, some people write an F and then write average down here. So which means the average value of the function f. But either way, is equal to is 1 over 2 plus 1. Why is that a plus 1? Because it's minus -1 over of this integral of 1 plus x squared dx. And that's going to be equal to 1/3 times, and the integral of 1 is x. The integral of x squared is x cubed over 3. And that's, of course, evaluated between -1 and 2. And this is going to equal 1/3 times 2 plus 8/3 minus -1 minus 1/3. And that equals let's just clean this up a little bit. That's a 2 plus 1 plus 8/3, and then plus 1/3, which is nice because that's 1/3 times 3 plus 9, which is 12/3, which is 4. So the average function value is 4, and that's wonderful. Before I go on to the next thing, I just want to notice I caught a little mistake, and I just want to fix it. This is 8/3 plus 1/3 is 9/3. 9/3 is 3, so 3 plus 3 is 6. So it's 6 divided by 3. So it's not, so it's actually 2. So the final answer is 2, not 4, but 2. Now I wanna look at the picture here. So what I'm gonna do is I'm gonna go to professional drawing. I'm gonna go to Desmos. And Desmos draws very nice and beautifully and professionally. So I'm gonna go to Desmos, and let's see if I could just I'm gonna share my screen with you now. And here is Desmos. And we're going to put in y equals 1 plus x squared. And what I'm also going to do, and I'm going to put in the interval, I'm going to put in x equals -1. And, I wonder what would happen if I do. I never did that. Oh no, I want x equals -1, and I want to put in x equals 2. So this is what we're looking at. And then I want to put in y equals 2, which is my average value. So what we're looking at here, and now I want to make these all dotted lines. 1. Okay, so we're looking at here. We're looking. So this is where, looking at that point there, and that point up there. That's what we're looking at. So we're looking at this whole, everything that's under the red curve in here, and that's y equals 2. So if you look at what's, boy, this thing just doesn't. If I would let this little triangle, it's not exactly a triangle, it looks kind of like a triangle. If I would let it melt down, I guess it would fill up this little bubble here, and I would get this solid rectangle. The solid rectangle here, which has the base is 3 and the height is 2. And the average value is 2, and that's the so there you go. That's beautiful. Well, that is very, very beautiful. Okay, let's how do I there you go. Now I have a little thought-provoking question for you. Um everything falls into this little rectangle here, and the area of this rectangle is 6, but I thought the answer was supposed to be 2. I thought the average value was 2, so why is the area of the rectangle 6? You know what I'm saying? That's a little conundrum there. Can anyone? That would be a nice question for one of our discussions, actually. Why does that happen? But I'm going to tell you why, and then I'll trick you with some other. I'll give you some other tricky questions later. Um, 6 is the integral. 6 divided by 1/3. Remember, we have to multiply the integral times 1/3. And when we multiply it by 1/3, that's where we get 2. So 6 times 1/3, that's where we get the 2 from. But the area of this rectangle is really that's the integral. That's the value of the integral, and that's 6. And it makes a lot of sense. It's a very beautiful concept. Maybe we could squeeze in one more problem. Let's find the average value of the function f. Oh, cube root of I wrote cube root of 8. Cube root of x cube root of, let me just write it nicer. Y equals the cube root of x. Let's write it a little nicer. So we want to find the average value. So the average value, so I'll write FF is equal to the integral. Oh, I always write the integral first. I should write the fraction first. 1 over 8 minus 1 times the integral from 1 to 8 of, now I'm going to write it x to the 1/3. I'm going to write it as an exponent because it's easier that way, dx. And this is going to be 1/7 times, now the integral, the antiderivative is going to be 3/4 times x to the 4/3. How did I get 4/3? Well, 1/3 plus 1 is 4/3. And then we have to divide by 4/3. But dividing by 4/3 is the same thing as multiplying by the reciprocal. So, and there's a value between 1 and 8. So this is going to be equal to 3 over 28. Where did the 28 come from? I multiplied the 7 times the 4. 3 over 28 times times 8 to the 4/3 minus 1 to the 4/3. Well, 1 to the 4/3, that's easy. 1 to the 4/3 is just 1. But what's 8 to the 4/3? Well, that means 8 to the 4/3 is the cube root of 8. The cube root of 8. Let me just what I'm trying to say is that this is 3 over 28 times, I'm going to rewrite it here just so you understand. It's the cube root of 8 raised to the 4th power minus 1. The cube root of 8 is 2. So this is 3/28 times 2 to the 4th power minus 1. And that's just 16 minus 1. So it's 45 over 28. And that's, well, that doesn't reduce, does it? That's the 3, yeah, that's my answer. So the average value of this function is 45 over 28. Let's go graph it on Desmo, see what it looks like. So I'm going to share my screen. I'm going to, let's see, let's just go to, I lost everybody. I'm going to share my screen and I'm going to let x equal 1 and x equals 8. I don't have to change that. Y is going to be 45 over 28. All right, so we got that all. And now let's actually graph this sucker and see what it looks like. So let's get, we want y equals, let's see, can I do cube roots on this thing or should I just do x to the 1/3 power? That's a square root. This thing has cube roots on it. If it doesn't, I'll just do 1/3 power, but I'm just wondering. Here we go. The cube root of x. So again, we're just looking at this part right here. That kind of makes sense. There's if I go from here to here, between these 2 points, and so I'm looking the area under this black curve. So the top part would kind of melt down and I guess fill up that little corner there, and I would have this this rectangle here, which would have a width of 7 and a height of 45/28, and that would be my I'm sorry, not 20. It would have a width of 7 and a height of, I guess, 45/4. Why did I say 45/4? Because 45 over 28 is the average value. That's the integral divided by the by 7. Well, everybody, it's been loads of fun. It has been absolute loads of fun. I cannot tell you how exciting and thrilling this has been. And that, my friend, is the story. Well, everyone, it's been lovely, and I will see you guys next time. Bye.